Okay, now we're going to do significant figures and calculations. Basically, when you add and subtract and multiply and divide, you have to follow some set of rules in order to know how many significant digits you will need in your answer. So in general, a calculated answer cannot be more precise than the least precise measurement from which it was calculated. So you talk about, having a really good instrument and a really poor instrument. And your answer can be no more precise than the worst instrument you used. So please make sure you understand that you have to look at precision of these numbers you're using. So it cannot be more precise. We're going to first look at multiplication and division. Now, if you have a number like this, where you have 24.65 times 0.67, when we multiply and divide, we look at the entire number. So you look at this whole number. How many sig figs are in that number? Well, there's 4. Then I look at this entire number. How many sig figs are in that number? There are 2. When I multiply these two together, I get this really, really precise and very highly significant number. But the problem is I can't have a number that significant. I only have one with 2 sig figs in it. So I take this very, very long number and I have to round it down to my least number of sig figs, which is 2. So my 16.5, the 5 will then round that 6 up and it becomes 17. So let's look at this. What is 4.54 times 5.775? When you put in your calculator, this number comes up. 26.2185. Well, that's not my real answer. I need to round it down. How many sig figs are in this number? Well, there are 3. How many sig figs are in this number? There are 4. My answer can only have 3 sig figs. 1, 2, 3. Will that 1 affect that 2? No, it will not. So my answer is going to be 26.2. Remember, when you multiply and divide, you have to look at the entire number. Let's try another one. If I have 4.0002 divided by 2.0, I get this number, 2.0001. Well, I can't use this entire number, so I have to look at my sig figs in each of these numbers. I have 1, 2, 3, 4, 5. I have 5 sig figs in this number, and I have 2 sig figs in this number. My answer can be no more significant than the least number of significant digits in my problem. So since this one has 2 sig figs, that's going to dictate how many digits I can have. 1, 2. Will that 0 affect this 0? Absolutely not. So my answer is going to be 2.0. Now that's when you multiply and divide. Okay? And a good rule of thumb is to watch your sig figs as you go through all your calculations. Eventually you can be a little more relaxed, and as you do multiple parts of a problem, you can kind of come back at the end and look at everything. But for now, watch everything as you go through the entire equation. Now, when you add and subtract, you do something a little different. You only look at the digits after the decimal point. For example, this number 2.045 has 3 sig figs after the decimal point. 3.41 only has 1 sig fig. There's 3 sig figs here and only 1 sig fig there. And this is my answer. Well, my answer can have no more significant digits after the decimal than my original number with the least number of sig figs after the decimal. So I can only have 1 sig fig after my decimal, right here. Will that 4 affect that 1? No, it will not. My answer is 36.1. This 1 digit after the decimal will dictate how many digits I can have. Let's try this one. When I have 65.98 plus 0.112, I get this number here, 66.092. Well, I have 2 sig figs after my decimal in the first number and 3 sig figs after the decimal in my second number. I'm only permitted my 2 sig figs after my decimal. 1 sig fig, 2 sig fig. Will that 2 affect that 9? No, it will not. So my answer is 66.09. 2 sig figs after the decimal. Another one. Let's do a subtraction this time. 89.224 minus 41, and it comes 48.224. I have 3 sig figs after my decimal in this first number. I have no sig figs after my decimal on this number, so I am not permitted to have any sig figs after my decimal. Will this 2 affect that 8? No, it will not. So my answer is 48. Okay, now we're going to begin metrics in science. You know we do not use the English system of measurement in our science rooms, and we only use metrics. We also call it the International System of Units, abbreviated SI. We say we use SI units. Now here are some SI units you're probably familiar with. There are 7 basic units of measurement. We won't be using all of these in chemistry, but we'll be using most of them. Length, obviously the meter, symbol, M. Mass, kilogram, kg. Time, second, the S. Now temperature, we use Kelvin. Kelvin is the SI unit. We'll typically be measuring in Celsius, but for the most part, when we get the gas laws, we'll be converting things to Kelvin. And of course, you remember amount of substance was the mole, and it's abbreviated MOL. We probably won't be using luminous intensity or electric current. Now, some non-SI units we will use in science are like the liter for volume. Typically, it's measured in cubic centimeters, but we will use the liter to measure liquid volume. Temperature, as I said before, we measure things in Celsius, but if we have to convert them to Kelvin, we will. In energy, we'll use the calorie, and pressure is atmosphere. The reason we really like metric system is, one, it's based on the power of 10, and secondly, we can use prefixes to make our numbers bigger or smaller, which is very easy and nice to do. This is a list of some of the different prefixes that we'll be using with our basic units. Our basic units are the meter, gram, and liter. So we'll have like megaliter, or kilogram, or decimeter, or centigram, things like that. We'll be using prefixes, and you can, for a while, you'll be able to use your prefix chart I gave you that looks very similar to this. But what I like my students to do is this. I like to draw a number line, because number lines make sense to us, or at least make sense to me. And we have in the very center our basic unit, all right, BU, okay? Our basic unit is our meter, our liter, and our gram. Then we have other lines extending like this. Now it's really not a number line because we are not setting it up like a number line. It's more of a counting line, as I would like to call it. It'll get smaller to this end and gets larger on this end. Okay? Now deci is my first prefix I'll be looking at, then centi, then milli. We'll skip a couple and we'll go to micro, skip a couple more and go to nano. Then on this side we'll skip a couple and go to kilo, skip a couple, go to mega, skip a couple and go to giga. Giga is 10 to the 9th, mega is 10 to the 6th, kilo is 10 to the 3rd. Each one of these lines here represent a power of 10. The basic unit is 10 to the 0. Deci is 10 to the -1. Centi is 10 to the -2. Milli is 10 to the -3. Micro is 10 to the negative 6th, and nano is 10 to the negative 9th. We're going to use these different values to help us convert between the units. Now, quantities can be expressed in different ways. For example, something you might be familiar with, $1 equals 4 quarters. You know, if I say, hey, you have a dollar? And you say, no, but I have 4 quarters. That's exactly the same. 4 quarters could equal 10 dimes. $1 could equal 10 dimes. 10 dimes could equal 20 nickels. 20 nickels can equal $1. $1 equals 100 pennies. 100 pennies equal 4 quarters. These are all the same. It's just different ways of saying it. These are called equivalents. Equivalents mean they're the same. Basically, the ratio between the two will equal 1. So if I have $1, we say $1 is equivalent to 10 dimes. These two together, the ratio equals 1. I could also say 10 dimes equal $1. It's the exact same thing. As we say, it's 6 one way, half dozen another. It doesn't matter which way you put them, they both equal 1. And again, you can see this. 100 centimeters could equal 1 meter. Or 1 meter equals 100 centimeters. It doesn't matter which way I say it, they're both equivalent to 1. We call these conversion factors. These conversion factors are the ratio of equivalent measurements. And this shows you a little bit more perspective about, here's 1 meter, and here's 100 centimeters. They're the exact same thing. 1 meter, 100 centimeters, 100 centimeters, 1 meter. It doesn't matter which way you go, they're the exact same value, 1. Okay, now let's look at these different conversions here. Now, I'm going to draw my number line up here again just because I want to show it to you. Basic unit. And then I have my lines coming off like this. And I'll put some over this way. And you're going to have to memorize this, so you won't be able to, have it on your test. This is deci, centi, milli, micro, and nano. In kilo, mega, and giga. Okay, so now what we're looking at is this. If I've got 3.68 kilograms and I want to know how many grams it is, here's how I want you to set this up. Here's how you must set this up. 3.68 kilograms times, I want to multiply it by something to get rid of kilograms and get the grams. So my grams goes on top and my kilograms go on the bottom, because I know if I multiply kilograms numerator by kilograms denominator, they cancel each other out, don't they? Now, what do I put in front of these? Well, which is larger, a kilogram or a gram? A kilogram is over here, and a gram is right here. This is your meters, grams, and liters. So kilo is larger, so kilo gets a number 1 put in front of it. We're trying to make an equivalent statement right now. And I say, okay, 1 kilogram equals 10 to the what grams? Well, how many spaces are between kilo and gram? 1, 2, 3. 10 to the third. This is my equivalent statement right here. So I'm going to have 3.68 kilograms times 10 to the third grams divided by 1 kilogram. Remember, these will cancel each other out, and it leaves me with 3.68 times 10 to the third grams. That is my answer. Okay, over here I have 5.68 centimeters, and I'm trying to get the meters. So I want to multiply it by, meters will go on top, that's what I'm looking for, and centimeters goes on bottom. What's larger, a meter or centimeter? Well, if you look up here, here's meter, there's centimeter. So a meter is larger. We give it the 1. Put a 10 beneath here. How many spaces are between meters and centimeters? 2. So I put a 2 here. So I have 5.68 centimeters times 1 meter over 10 to the second centimeters. Sorry, my pen keeps getting wiggly. Cancel my centimeters out, and I get 5.68 meters divided by 10 to the second. Well, I can either just divide 5.68 by 10 to the second, or when I bring 10 to the second up to the numerator, my exponent becomes negative. So it becomes 5.68 times 10 to negative second meters. Okay? And let's look at this last one here. So I have 8,700 milliliters. So I have 8,700 milliliters, and I want to change it to liters. So I put milliliters on bottom. Liters is larger than milliliters, so I put the 1 with liters. How many spaces are between liters and milli? There are 3. So I'm just going to go ahead and cross the milliliters out now instead of doing this step right here. So it becomes 8,700 liters divided by 10 to the third. Well, I can just either divide 8,700 by 1,000, or I can bring this up, and it becomes 8,700 times 10 to the negative third liters. But can I leave it as 8,700? No, it's got to be between 1 and 10. So when I actually make this between 1 and 10 with a negative 3, it becomes 8.7 liters. Okay? Now I'm going to give you a few seconds to do this next page, and pause me for a second, give them a try, then come back and check your answers. Okay, I hope you've checked them, and let's see what we have. Let me change the font here, or the color a little bit. Okay, we'll change it to this blue. Won't that be lovely? Okay, and let's look over here. We have 600 grams, and we're going to multiply it by kilograms. That's what I'm looking for, over grams. Okay, and what I'm going to do is, what is larger, kilo or gram? Kilo is larger. How many spaces are between kilo and gram? There are 3. Go back to your paper and look at it. So this becomes 600, my grams cancel out, 600 kilograms divided by 10 to the third. And it becomes, if I divide 600 by 1,000, it becomes 0.600 kilograms. Okay, so let's try the next one. 8,900 millimeters. Let's get that to meters. Millimeters is on the bottom, so I can cancel them out. What's larger, meter and millimeter? Well, meter is. How many spaces between meter and millimeter? There are 3. Now guys, I don't want any negative numbers on this part. No negative 3s, no negative whatevers. This exponent always remains positive. My millimeters cancel out, and I have 8,900 divided by 10 to the third meters, which becomes 8.9 meters. Do you have to go through this every time? No, once you get this part, if you get right to 8.9, I can see what you're doing. And then finally, 0.250 kilograms. And I want to get to milligrams, so I put kilograms down here. Kilograms is larger than milli. 10. Now between kilo and milli is 6 spaces. 3 to gram, and then 3 more to milli. So my kilograms cancel out, and I have 0.250 times 10 to the 6th. Can I leave it like this? Because can I actually keep my 0.250? No. I have to make this between 1 and 10. So it becomes 2.5 times 10 to the 5th. I hope you got that, and we'll be working on these in class.